Guys, today we are back with another problem. Before I go and solve this problem, make sure you guys like, share and subscribe to the channel. And today's particular problem is a total count problem. So it's a problem, it's an easy problem, okay? It's an easy problem based on arrays. So what it is saying that we will be given an array of I of positive integers. Make sure you guys underline the important parts as you note down the question. And a threshold value of k. So we'll be given an array and a threshold value k. So if this is my array 5, 8, 10 and 13, so we will be having a threshold value of k. In this case, the threshold value let us assume as 3. For each value of the element in the array divided into minimum number of small integers, such that each divided integers is less than or equals to k. This is also another condition. Compute the total number of these integers across all the elements of array. Okay, so let us understand this particular problem statement. Let us understand this particular problem statement with the help of an example. So if this is my array, it is saying the array is having the elements 5, 8, 10 and 13, and k is my value. Okay, k is the value which allows me to divide it into some possible manners. Okay, so say for example, I have this array like this. I have to divide this array into such manners where each divisions go up till the value k. Okay, so let me explain you nicely. Okay, so I have 5 can be divided into what values? Okay, 5 can be divided into what values when k is as 3. So first let us take a larger value. We can take 3 straight away. Okay, and what other value will I make to make this as 5? 2. So you will ask me enough how this is coming. So 3 plus 2 is 5. That's how it's coming. Okay, and you can see that k is 3. So 3 is also less than and equals to 3. That means I can take a 3. And what I am left with is nothing but a 2, because I can't take any larger value. I can take 1, but in this case, if I take a 1, it will not fill this particular array. Okay, and the condition is you have to fill with the larger values. Now let us take 8. Now I have 8, right? Now I have the value 8. So what if I have 8? How many combinations I can divide 8 into? I can divide 8 into, first let me fill with the larger value. The larger value what I can get is 3. Okay, another 3. So it becomes 6, then becomes 2. Similarly, I have now left with 10. 10 can be filled with what type of values? 10 can be filled with 3, 3, 3, okay, and 1. So 10 can be filled with all these values. And I'm left with 13. I can just straight away start with 3, 3, 3 and 1. Okay, so I'm also filling 13 in this particular manner. Now what is my output? Output is nothing but the count of the total number of elements in each divisions. So here the count is 2, here the count is 3, here the count is nothing but 4, and here the count is nothing but 5. So I'm having a 9, 10, 11, 12, 13, 14. So the total count is nothing but 14. So this is what the question is all about, total count. How we can solve this question? It's a very easy problem. Let us not think so much for this particular problem. What we can clearly understand that if k is there, okay, what is the easy way to solve this problem? Trick. I will just write it as trick. The trick will look like this, that okay, if I have 5 and my k value is 3, is my 5 completely divisible by 3 or not, or the value which is the k value? Okay, so if I check, if I do the division of 5 and 3, what I'll be getting is I can put only one value of 3. That leaves me with a remainder of 2. That means I have to put 3 over here. That means when I am writing 5, I can write it like this, that I'm going to put 3. Okay, along with that, what I'll be putting is I'm going to put another value which is 2. That makes it 5, right? But how is this coming? Okay, so let me do the division. In case of odd numbers, what I can say, in case of numbers which are not divisible by k, and divisible by k. So first let us understand one thing, whether array of I is completely divisible by k. If the array of I is completely divisible by k, what I am going to store in my answer is, I will store just answer plus equals to array of I by k. Okay, that means let us take example number 10. Let us take another example number 10. So in all these examples, what I can see is these are not completely divisible. So I am going to take. So that's another case. So this falls under the second case. If it is not completely divisible. So I will write not completely divisible by k. So in this case, what I'll be doing is I'll be updating my answer plus equals to array of I by k plus 1. I'm going to show you with proof. So let us take example number 10. For 10, what I am leaving up with 3, right? 3 is my k value. What I'll be getting is 3.33 something. But you have to remember, this is an integer value. I'm using integer variables. So I'll be storing the output as equals to 3, okay? Plus 1. Why plus 1? Because it is not completely divisible. 10 is not completely divisible. That means 1 equals to 4. That means there are total 4 slots are available. That is how I am getting this particular 4, okay? Now let us see for 13. For 13 also, I'll be divided with 3. So what will I get when I divide it with 3? I'll get 4, okay? Now since it is not completely divisible, 13 is not completely divisible by 3. I'll add 1 extra. So what I'll get is a 5, okay? So you can see there are 5 slots which are available, okay? Now let us take example number 8. So for array of 8 by 3, what I'll get is, I'll get a 2. I'll get a 2. Why? Because 3 2s are 6. Again, what is my remainder? Plus 1. That means I'm getting total of 3 slots. I'm getting total of 3 slots. That is also fulfilled. Now I'm left with nothing but the smallest value, 5 by 3. Okay. What I will get is 5 by 3 is only I'll get a 1. Okay. Now I'll ask me why 1? It's not 1. No, we have to take the integer value plus 1 because it is not completely divisible. It falls under this condition. Okay. So what I'll get is nothing but I'll get a reply of 2. So you can see I'm getting the slots 2. Lastly, your task is to add all the slots. That's the reason I'm doing answer plus equals to. That's the reason I'm doing answer plus equals to get all the summation of all the slots, which makes up to 14. Which makes up to 14. If you add all the slots, 4 plus 9, 12, 13, 14. Okay. So it's a very simple code. Now I'll put forward the algorithm for it. I'm making a function which is passing an array, and I am storing the length of the array in this variable. I'm iterating the array till the length of the array. I'm checking it whether the modulus. Why I'm using modulus? Modulus just help us to get the complete remainder is 0 or not. If it is remainder is 0, that means completely divisible. And in our case, when we are doing with this particular example, where the result plus minus equals to array of I by k plus 1, that means it is not completely divisible. Okay, so we are doing this, and in the end we are going to just return the result. That's how simple this particular problem is. If you could understand this problem statement, make sure you guys like this particular problem, share with your friends, and subscribe to the channel. I'm just going to quickly submit. In order to show you this actually works or not. So I have already made comprehensive playlist on multiple topics of arrays. Make sure you guys like, share, and subscribe to those playlists as well. Thank you so much, and I'm looking forward to see you in our next video.